Hello and welcome back to How to Academy's Change the World 2020. It's a melting pot of ideas from society, politics and to the environment. And the next talk is about how to change this world from beyond its limits. Sophie Hackford is our speaker. She's a futurist. She is the co-founder of 1715 Labs, a spin-out from Oxford University's astrophysics department that is now a data and AI company. And Sophie is going to be talking about satellites, sensing and spaceports. Extraterrestrial tech changing life on Earth. Over to you, Sophie.
Thanks very much. So I'm going to talk, as you just heard, about the private space industry because it's getting very, very busy up in space. And I'm going to show you how much is going on up there and how much it's doubtlessly going to change our life here on Earth. It can sometimes feel, when you're thinking about the private space industry, a bit like a sort of mashup of the Californian gold rush and a giant laboratory. A mix of profiteers rubbing up against those asking profound questions about the origins of everything. I was very lucky to work on a NASA campus back in the early days of the private space industry. I had a rocket, as you can see here, out of the back window of my office. I had a NASA shuttle that took me back and forth to work every morning, which always made me laugh. And I was lucky to be able to visit the SpaceX factory in the early days when they were still allowing visitors and see some of the earliest launches that were happening at the sort of end of last or 2 decades ago now. But it taught me, this private space industry sort of birthplace, taught me that I was thinking about space not as an academic luxury or just the playground of billionaire prospectors, but that it is a bustling, living lab. And that's what I'd like to talk about today. But I do get it that when you read about China going to the moon, as it is, of course, right now, bringing us back rocks for the first time since the 70s, or if you read about Elon Musk or Jeff Bezos with their private space sort of travel ambitions, and, of course, Musk's ambitions to die on Mars, just not on impact, that it's tempting to think we've got enough to deal with on Earth. We've got enough with COVID and climate change and poverty and food insecurity, that space exploration or discovering the far reaches of our galaxy is somehow a nice to have or a vanity project. And I think there's 2 reasons why that's actually missing a trick. I'll explain that quickly before I show you some of the things that I'm excited about. The first reason I think that's missing a trick is that space assets like satellites, for example, are things we depend on from the moment we wake up in the morning. That if you visualize the global economy, you've got to visualize it stretching off the planet. That actually we've got to include these satellites, we've got to include sensors, we've got to include space stations, spacecraft. If space was switched off, in a sense, we wouldn't have GPS, we wouldn't have weather forecasting, we wouldn't have telecoms infrastructure, military maneuvers would be compromised, logistics would be almost switched off. We depend on space in a tremendous way that perhaps we don't really understand in terms of the global supply chain. And the second reason why we shouldn't ignore the private space industry is that I think it might actually generate some new ideas that we are, of course, in dire need of today as we face some pretty sticky challenges. That as we try new technologies, like robots, for example, operating remotely on different planets or in orbit, that if we can do it in space, we can surely do those things on Earth. So it's almost like a playground or a sandbox for some experimentation. And I think, and this is the key point of the talk that I'm giving today, that if you limit yourself to terrestrial R&D, if you limit your thinking to terrestrial thinking, you might miss some breakthroughs that are coming from experiments or prototyping that's happening off Earth. And today, this space economy, this place where buccaneers and space agencies meet, is absolutely fascinating in my view. Last week, Elon Musk delivered in his SpaceX rocket 4 NASA astronauts to the International Space Station, the ISS. And that was a totally autonomous process. His rocket flew them there without the crew having to touch any buttons or anything else all the way up. But at the same time, SpaceX is upsetting astronomers hugely with the trails from their Starlink satellites that are streaking across the night sky, perhaps jeopardizing discoveries that will come from some of the large new sky surveys that are happening, like the LSST, for example. So certainly a very interesting and emotionally charged relationship between private space companies and the space agencies, because they're both building infrastructure that both are using. And this is a fascinating time, in my view. I'm going to spend the rest of my talk showing you some of the incredible experimentation in a new space economy that's happening, from cancer to connectivity. And of course, I can only cover a fraction of that in the 25 minutes or so that I have here. I'm not going to talk about space war. I'm not going to talk that much about rockets or the interplanetary internet. But I'm going to end after some of those experiments by talking about some profound questions, I think, about us as a species and a tiny little bit about looking for aliens, or at least listening for them. So let's kick off. What is the space economy? What does industrializing low Earth orbit even mean? What is this new economy that NASA is already valuing at around $345 billion? Well, I'm going to start by talking about some technologies that are already in play up there, and then I'm going to talk about some slightly madder things that I think are quite cool that we could learn from here on Earth. And the most obvious place, of course, to start is satellites. We're sending satellites up that are both watching us but also connecting us. The ones that are watching us, observation satellites, are going up in rockets and in horizontal launch flights like this Virgin Orbit one here, that are watching us and the natural world. So they're looking at us, buying burgers, as you can see from this burger traffic index rather, from Orbital Insight, where they can see who's buying burgers in which burger joints in the US. From that to looking at how glaciers are changing size, changes in tree canopies, even being able to measure penguins' heights from space. Some important work here done by Brooke Simmons during Hurricane Dorian, using satellites to figure out where rescue helicopters can land without them having to circle a lot of times to be able to see where people or damaged buildings might be. All kinds of economic and other activity being tracked by space that's really fascinating. But also what we can see from space, which I think is doubly interesting, is inaction, is political paralysis or political corruption that's happening, action that's not happening against some of the challenges that we're facing today. So really interesting transparency this is bringing to the world. So fundamental are these satellites to our global economy today that Amazon has brought out a new product called Amazon AWS Ground Station. So if you do want to start a business in this space, Amazon will do all your satellite communication and data processing for you, stop you having to set up your own ground station, which is, of course, a relatively resource-intensive process. And these satellites aren't just watching us, of course, they're connecting us with each other. They're weaving a kind of intricate sort of lattice of communication infrastructure off Earth in a really fantastically interesting way. We're going to be dependent increasingly on these satellites for everything from autonomous vehicles to drones. All of that communication between devices as we connect more and more to the internet is going to be powered by satellite communication in space. We simply don't have enough room for the ground stations we would need here on Earth to be able to power that kind of technology. And in the future, we might use satellites like these ones on the slide here, quantum satellites, which is pretty much the most buzzwordy thing I could probably say that's possible to say, that will be securing our communications as we rely more increasingly on these sorts of technologies. And because we rely so much on them, we have to protect them at all costs. It's incredibly busy up there, as I mentioned before. This is an artist's impression of what they call space junk and satellites. But actually, it's based on real data. There is a lot of bits of old satellite or bits of rocket crashing into important assets like the International Space Station. And if we're not careful, that could damage some quite serious infrastructure up there. And we also need to protect our assets up there from non-human threats. Things like the Earth's magnetic field, the solar flares, for example. We need to get better at predicting that kind of thing with swarms probably of sensors that will be up there off Earth to protect our digital infrastructure, our digital economy from solar flares or any other sort of space weather. The second thing that I think is really interesting that's happening that's important right now is biology in space. On places like the International Space Station or the planned Lunar Gateway, which will be a staging post that will be orbiting the moon in the years to come. This and the ISS are floating laboratories. In the ISS's case, it's doing science it wasn't designed for at all 20 years ago, whether it's robotics or many other types of experimentation. Because you can do very interesting things in the interesting conditions that these laboratories provide for us. Microgravity is an obvious one, but also cosmic radiation or low or very high extreme temperatures that we can generate or experience up there. And we've seen a lot of this experimentation happening in really interesting biological ways. This is an organ on a chip. The idea that you could put heart cells or lung cells or even brain cells into a chip type of device that's like a model for a human organ. If we can look at how that behaves differently in microgravity, some really interesting learnings for how, of course, we on Earth here operate. Because apparently space station grown cells grow better up there than they do here on Earth. And of course, you can test them in 3D as well, which is incredibly important for scientists who are used to doing those experiments in 2D, in Petri dishes and other things. They've been testing Alzheimer's cells up there to see how they get neurodegenerative disease. Cancer researchers have been looking at how blood supply reaches tumors up there. Drug companies like Merck, for example, have been studying protein crystals to make drug delivery more effective. Everything happens faster in space. Cells age quicker, bacteria spreads quicker. What that means is you can accelerate experiments. Things that might take months on Earth to be able to do, maybe vaccine candidates, for example, can possibly be accelerated in space. And other hardware is doing interesting things too. This is an Oxford nanopore experiment doing some DNA sequencing. They've sequenced more than 1 billion base pairs of DNA in space now. That means they can sample things on the International Space Station, find out if there's any sort of extraterrestrial microbes on board, but also, of course, eventually take those devices off the ISS and into the rest of our exploratory plans to see if there's any DNA or RNA-based life beyond Earth. So fascinating potential. And not just cells. This is Yvonne Kegel, a space surgeon, as well as an astronaut. I was lucky to work alongside her when I was back on that NASA campus. She's created a device that can help heal bones or sprained tissue, which is things obviously very difficult to fix on the space station that people like her are able to innovate our way out of. And of course, the medical dream, wherever you are, either on Earth or in space, is to be able to create organs for transplant, to be able to grow them or print them with a machine. And some people are thinking about how we can do that on the International Space Station because, of course, there's no gravity, and therefore it's quite a nice growing environment for organs. Here is a rather interesting picture of an astronaut, a lady called Christina Koch, holding what they call media bags, which are obviously bags of human cells used in this biofabrication facility to actually manufacture fully functioning human organs in microgravity. Still experimental, but imagine what kind of a breakthrough that would be, and obviously something we could then replicate here on Earth. The third thing that I think is really interesting about space is manufacturing. At the moment, there are some incredibly exciting companies, one of them being Made in Space. Again, I was lucky to work alongside them back in the day. They make satellites that manufacture themselves in orbit. So what you do is you send up like a little mini factory, as it were, full of raw materials. And when it's up there, you beam the designs to it, you email the files to it, and it will create very large, intricate satellites or telescopes, things it's very difficult to send up in a rocket because maybe the trauma of takeoff is too great, or maybe they're just simply too large to fit into a rocket. And that is a fantastically interesting set of innovations, again, that I can imagine would have a tremendous impact here on Earth. We could also manufacture things for Earth in space. This is something called ZBLAN. It's a type of fiber optic cable. I also just quite like the fact that it looks very sophisticated here on a slide. The communications infrastructure that we indeed are relying on here during this talk are on optical fiber cables, and over a certain distance they start losing their signal quality. And that's because they have these little crystals apparently that grow in the manufacturing process when you're doing it on Earth. If you make this stuff in space, apparently those crystals don't grow. So there is this idea that possibly in time we'll be manufacturing things in space for Earth that actually are impossible to manufacture on Earth. And that becomes very interesting when you start thinking about a market that might be unique to on-orbit manufacturing, something completely new, which I think is fascinating. But it's also about making things on the International Space Station. This is a wrench held by an astronaut, Wilmore here, that was made back in 2014 when Made in Space, that previous company, put a 3D printer on the International Space Station. That means that that was actually the first thing ever manufactured off Earth. Since they've made 115-bit tools and spare parts and everything else on the space station. And of course, again, if you can do things on the International Space Station, you can pretty much do them anywhere. You could 3D print an item that you need if you're in the middle of the desert or you're up a tree in the Amazon or wherever you are. Not wishing to be outdone, Relativity is a company that wants to 3D print whole rockets. They're not alone in their ambition. They've just raised $500 million, so clearly some people think they're onto something interesting. They've built an autonomous, or are building an autonomous rocket factory. The idea that if you take a rocket to Mars, that's all very well, but what if you want to go home again? What if you wanted to take another rocket and go off somewhere else? Well, actually, you need to be able to build these things remotely, not on Earth, and ship everything off into space. And again, I ask the question, if you can 3D print rockets on Mars autonomously, which is the plan, then surely we can run autonomous factories here on Earth. And so fascinating interplay, I think, between terrestrial and extraterrestrial innovation. Now, I promised to explore some more outlandish ideas, so I'm going to do that now. Of course, very quickly, science fiction can become science fact. We can think outlandish things. We're in space in a kind of infinite laboratory kind of sense. And actually some unexpected things have already happened, before I go a bit crazy as I promised, that you probably wouldn't understand or know necessarily. And there are Wikipedia pages that show you that Tempur-Pedic mattresses, that LASIK eye surgery, that even the coating on the Oscars statuette are all offshoots of space technologies. The first outlandish thing I wanted to talk about is energy. We clearly need to up our renewables game here on Earth. Satellites today are, as I mentioned earlier, pretty much just information services, but at some point they could start actually delivering physical resources from space, so-called beamed power. And whilst that might seem completely crazy, the European Space Agency here has issued a call for ideas in this specific realm. And the idea is that you beam solar energy from space onto terrestrial solar farms, particularly at dawn and dusk, when, of course, demand is quite high for electricity when you get home from work or when you're waking up in the morning, but of course the sun isn't shining. And the idea might be that you could beam that stuff from space, but also use it to use solar energy in space. So maybe to crack water into hydrogen and oxygen and make fuel out of it, or various other resources that you might want to use on orbit, not just on Earth. The second outlandish thing are these, asteroids. The idea we might mine them for resources is something that's genuinely being explored by lots of companies. There is, helpfully here, a website called Asterank if you want to go and check out which asteroids are worth getting out of bed for. They list them by dollar value here, so you can see what kind of minerals or water or whatever else is on board each of the asteroids circling or floating about in the far reaches there, which obviously is a very helpful resource for the entrepreneurs out there. But it isn't just resources like minerals and rare earths, it's also water, something very useful for making fuel. Apparently, I think this is rather ambitious as a statement, but asteroids are the low-hanging fruit of the solar system. They're just sitting there waiting for us to exploit, and we're simply just we're not quite entrepreneurial enough quite yet to go after them. But the third outlandish thing I wanted to mention was colonization. There's some beautiful images that I pinched from a 1976 report written by NASA on the benefits of colonizing space, the age-old sort of human thought experiment that we might start living off Earth. And I think there are lessons for our resource-constrained planet that we could think quite carefully about. If we think about water, for example, apparently 93% of the water on the International Space Station is recycled. Clearly they can't keep sending up rockets full of water to feed the astronauts, so they recycle an enormous amount of their water. Again, something we should perhaps learn here on Earth. And the second thing is space agriculture, something quite interesting, rather beautifully illustrated by these NASA images here, which I think are rather wonderful. This is actually really what it looks like. This is Jessica Meyer, a NASA astronaut, pruning her mustard leaves on the International Space Station. Again, we could learn tremendous amounts about agriculture, I think, by doing it in places that are very difficult. And we're clearly going to need robots to help us up there as well as we're developing all these technologies. And the other thing I think very interesting that we'll start seeing are the new legal and business norms that will start popping up around things like colonizing other planets. Mars, for example, here Elon Musk has been accused of Columbusing, which means colonizing something that's not really yours to colonize, by suggesting in some of the small print of SpaceX that actually it's a free planet and it's sort of a free-for-all for whoever gets there. And clearly some space lawyers need to be put in place to try and think about how that might play out. But finally, I wanted to talk a little bit about how actually even just staying on Earth but looking at space is a sort of interesting experience in itself. This is part of the Square Kilometre Array. It's a set of dishes that are based in South Africa and Australia and will eventually be a very powerful telescope. And every second, apparently, they're going to download the same amount of data that the whole web handles in a day. So clearly, in our very data-heavy world that we're living in today, there's a tremendous amount that we could learn from radio astronomers who are dealing with huge data sets in the same way that we're going to be dealing with huge data sets that will be streaming out of all of our devices. So I think, again, there's these lessons from radio astronomy and others that we could learn. Another lesson that we could learn, interestingly, I think probably surprisingly, is from places like the search for extraterrestrial intelligence. Again, some neighbors of mine when I was out on NASA Ames. As my co-founder said recently, interesting things happen when you don't know what you're looking for. They are, of course, looking for aliens or the signs of alien life in what astronomers call the Great Silence. And of course, that means their kit has to be sensitive to a whole range of signals that you can't necessarily predict what they're going to be. And again, the transferability of those skills is super interesting as we kind of push forward in this very data-heavy world that we're moving towards. So I can imagine a future where we host data and people in space, we beam energy from space, we manufacture massive satellites in space and spacecraft even in space, but we also remotely manufacture things that we use on Earth. In fact, and forgive the long quote, but Jeff Bezos said something fascinating. He doesn't think we should do any manufacture almost on Earth. And I don't know how serious he was when he said this, but he said all of our heavy industry perhaps could be moved off planet. Earth will be zoned residential and light industrial, and we shouldn't be doing any heavy energy on Earth. We could just build it all in space. I'm not quite as optimistic perhaps as him, but the idea that we can manufacture things in different ways is very interesting to me. So I'm going to end on a more poetic note, I think, because I think there's a lot of beauty in a lot of the space exploration as well. Because I think without the ability to go off Earth, we can't look back and see in real time what we're doing to it. Climate science is the child of space exploration, as Cantino and Lachman said here. The 1970s gave us the blue marble. It gave us the kind of galvanizing moment for the environmental movement. And being up there, being on the International Space Station where humans have been continuously for the last 20 years now, we can reflect back on the planet. We can reflect back even on us as well as a species. And some people say that exploring the cosmos is actually a way of getting to know ourselves better as a species. And I'll talk about that a little bit now because I think it's fascinating. This is all really brought home to me very recently by the recent failure of the Arecibo dish in Puerto Rico. For those of you who don't know what happened, sadly, this enormous dish, unfortunately, all the cables have now snapped and that piece in the middle has fallen into the dish in the middle and smashed it, so it is now out of action. For those of you who have been observing this sort of thing in Bond movies, this was where they had a tussle in GoldenEye back in 1995. But anyway, that's not the point I'm trying to make. It collapsed, which is very sad because it was somewhere where astrophysicists and others have been studying galaxies millions of light years away. It was where they first discovered exoplanets or evidence of neutron stars, and also was helping us spot near-Earth objects, which seems like a useful thing to do given how destructive that could be. And writer Sharon Stironi, in her sort of eulogy almost to the collapse of this dish, said that telescopes and spacecraft aren't just tools, they're extensions of ourselves. Because if we think about how we explore the galaxies with spacecraft or telescopes, we're never really going to be able to get there ourselves. Like the Voyager has, of course, been underway for nearly 40 years now, which is absolutely magnificent. But these are places we will never get to, certainly not in our lifetimes or probably in many others to follow. But we're all made of stars, as the saying goes. We're all made of the same stuff that was all created in the Big Bang. And by exploring and looking out there into space, we're looking for ourselves almost, as Stironi says, in the family of the cosmos. And I rather like that. But just to get slightly more trippy before I finish, some people say that as we spend more time in space as a species, as we spend more time on Mars or in other places, we may actually start to engineer ourselves genetically in order to survive better out there, whether that's surviving with less oxygen or whatever it might be. In fact, Lord Martin Rees, our Astronomer Royal, talks about this concept. And long term, we could think, actually, if we're changing ourselves radically, if we're changing ourselves even genetically, people like Yvonne Kagel, who I mentioned before, asks these sorts of questions. Well, actually, what if the alien we're in search of is ourselves? And I think that's a very beautiful and rather poignant point to end my talk. So I don't want us to restrict ourselves to terrestrial R&D, and I hope I've made that point in the last 20 minutes or so. I don't want us to restrict our thinking to Earth, particularly as we face such difficult challenges, whether that's climate change or COVID management or inequality. There are tremendous innovations that are happening up there that we could use to improve our life here on Earth. Because I think that aliens and ideas and answers could lie out there somewhere in the great silence. Thank you very much.